Old is gold. But not in this case. Making a vaccine from this to this is, well, pretty complicated. But this new solution might not be so complicated. When we think of a vaccine, we usually think of a dead or a weakened virus that's injected, the immune system responds, and we're all good. Or instead of the whole virus, antigens or fragments of the virus are injected. But there's a third kind that hasn't been hyped till COVID, nucleic acid vaccines. Nucleic acids are the building blocks of DNA and RNA, which radio instructions to teams of cells working to build their own teams, composed of many unified proteins. When a virus like the coronavirus enters, it plays several matches with the body. This virus found a weak spot in a key player, the ACE2 enzyme. Using its spike proteins surrounding it, the virus infects the cell and scores the match. But vaccines give the immune system the practice it needs to score. Older methods are often time-consuming and costly. However, these new ones are revolutionary, dramatically shortening the time to create a vaccine. Let's check it out. DNA plasmid vaccines use a special kind of DNA, plasmids, which are small circular pieces of DNA. COVID-19's information for the spike proteins are in RNA, so the RNA is converted to a modified DNA, inserted into a plasmid, and placed in a solution that becomes the vaccine. When it's injected, the cell takes in the DNA and creates the spike protein, leading to antibody production and an immune response. Because DNA isn't directly involved in protein building, their weak response is compensated with a special delivery, and additionally, the incoming DNA has the potential to alter the original DNA. But the second vaccine eliminates these problems. Let's rewind a bit. RNA creates a vaccine known as an mRNA vaccine. They're created in a similar manner. The spike protein's genes are isolated, strengthened, packaged, and injected into the cell. And once again, we have immunity. Direct involvement in protein building equals a better immune response, and the original plans were never touched. But loose mRNA decays quickly both inside and outside the body. However, several solutions were created to combat this issue. mRNA can be delivered with molecules to stabilize it. Having a cap, a tail, and random information can protect and strengthen the expressed gene. Molecules outside the mRNA help effectively deliver it to the cell, the most common being lipid nanoparticles, which are like oils. Another approach, known as recombinant vector vaccine, uses the sly characteristics of the common cold viruses to carry mRNA. There are still many obstacles to overcome with nucleic acid vaccines, and as COVID-19 spreads and evolves, this new technology is the key to victory. But in the meantime, practicing social distancing, wearing masks, and hand washing all do their part in prevention, and sooner or later, we'll only be a shot away from winning the game.